All right, what's good, Logan? So, just a brief overview of what we're going to do today. We're going to try to graph these functions, cosine and sine, but we're going to graph them with the pretense that this right here and this right here, those two values, they're going to stretch the graph vertically. So understanding that the a, or the value that's multiplied to the function, this is going to stretch or shrink, so we'll just use the word dilate. These are going to dilate vertically. Okay, so that's the first thing that we need to understand is just a basic overview that the number in front of cosine or the number in front of sine, that's going to vertically dilate the function. And then the second thing we want to understand is that this guy right here, that b, and this guy right here, that b, what they're going to do is they're going to dilate the function. They're going to shrink it or stretch it, but they're going to do so horizontally. So this is going to be a horizontal dilation. So it's going to dilate horizontally. Now, if you want to write this in your notes, you can. It's not really a big deal. I just wanted to make sure that you had a brief understanding of what's happening today. First thing is that the a, the number in front of cosine, or the number in front of sine, those two things are going to dilate the function vertically. And then the b, the number that's being multiplied to the x value, the b, the number that's multiplied to the x value, that's going to dilate it horizontally. Now remember, the horizontal dilation is going to use the reciprocal of b. You're going to have to flip the b upside down to get the dilation value. Just a brief reminder, okay? So remember, when you dilate with b, you're going to use 1 over b. Remember, 1 over b means flip the b, all right? Now with the a, you don't have to do anything special. You just multiply by whatever a is to all those points and values. All right, so let's get into the actual notes for today. I'll go ahead and post this on Canvas for everyone. So if you don't want to write it down now and write it down later, you kind of want to just pay attention, you can do that. All right, so let's start off. We're going to be graphing sine and cosine functions. This is our strategy. Step number one, I need you to identify the amplitude and the period. This is like last night's homework. Figure out what the amplitude is, figure out what the period is. If you don't do that, not a big deal, but you really want to find out what the a value and what the flipped version of b is. Second step, there are 5 key points that you're going to want to find. Now, I wrote the word plus right there. Sometimes you're going to want a couple more points, so the plus is those couple of extra points. But there are 5 key points that I want you guys focusing on, and the points are going to be based upon the amplitude. That right there, the a value, the amplitude, that's going to vertically dilate those points. That makes sense. So if you look back at the notes, these things right here, they're going to vertically dilate those points. So the amplitude is going to be the vertical dilation of the points. Then the b value, the period, is going to horizontally dilate the points. That makes sense. The b value is our horizontal dilation. So we're going to say multiply by the flipped version of b. All right, now understanding on where these points come from, I'm going to list how we use the unit circle. So the unit circle, I'm only going to focus on 3 key points. Take that back, 5 key values. I'm going to focus in that direction, 0. I'm going to focus in that direction, 90 degrees or pi over 2. In this direction, 180 or pi. In this direction, 270 or 3 pi over 2. And then once again, we're going to rotate around there over to 2 pi. All right, now this is where it gets a little tricky. So what I'm going to do is I'm going to say for cosine, we want 5 points. So I'm going to write down what are the 5 points. So we're going to write down 1, 2, 3, 4, and 5. Now the x value that you're going to be plugging in, is the angle. So I'm going to be focusing on the angles throughout my unit circle. So we're going to focus on 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are going to be my key values for this. So I'm going to grab the red and I'm going to say 0. So we're going to go 0 for x first. Then we're going to rotate it onto 2 pi, and we're going to plug in pi over 2 second, not 2 pi, pi over 2. So 90 degrees. Then we're going to plug in pi. So we're going to rotate all the way around to there. And then we're going to plug in 3 pi over 2. So that'll be my next value to plug in, 3 pi over 2. And then we're going to plug in a full rotation, also known as 2 pi. Now, when I say plug in, it's not really plugging in under the normal circumstances, or it doesn't feel that way, because the values you get from plugging them in are already seen to us. Remember, the cosine function, this guy right here, is always going to be your x values. So when you plug in, you're going to plug in the red into the cosine function, and you're going to get the green as those values. So when you plug in 0, you get 1. When you plug in pi over 2, you get 0. So that's what we're going to write down next, is that plugging in 0 gives us that 1 value right there. So we're going to get 0, 1. Plugging in pi over 2 is going to give us that 0 value there. So we're going to get pi over 2 comma 0. When I plug in pi, I get the -1 value. So I'm going to put pi -1. And I'm going to keep doing this throughout the rest of the problem. 3 pi over 2 is going to give us a value of 0. And 2 pi is going to give us a value of, oops, not 0, but 1. So all I'm focusing now on is the angles in red and then the unit circle value in green. We're going to do this again for the sine function so that we understand what our basic values for the sine function is. Once again, it's going to be 5 points, 1, 2, 3, 4, and 5. And we're going to plug in the same exact angles. So we're going to start with 0. We're going to go to pi over 2. We're going to go to pi. Then we're going to march on over to 3 pi over 2. And then we're going to finally end up at 2 pi. And this time, instead of using the cosine values, also known as the x's, we're going to use the y values. Those are the sine values. So we're going to find all the sine values. You'll notice that the sine values are always 0, 1, -1, and 0, 1, and -1. So 0 is going to give us 0. So we'll do 0, comma 0. And then pi over 2 gives us the 1. So we'll put a 1 over here. So pi over 2 with a 1. And then at pi, we get 0. So pi, comma 0. That's our next one. And then we have 3 pi over 2. That's with the 1, -1. So we have 3 pi over 2 and -1. And the 2 pi is with the 0 that's over there. So we have 2 pi, comma 0. Now, what this does is it sets up our 5 key points that we're looking for when we're graphing these functions. Now, we're going to take these key points and we're going to transform them. We're going to dilate them depending on what the values are. So we're going to either dilate the cosine function if it's a cosine problem, or the sine function if it's a sine problem. Take a look at number 1. So number 1, we're being asked to graph f of x equals 1/3 cosine 1/2 x. So the question that I would be asking is, well, which do I use? Do I use the green one or do I use the yellow one? We're going to go ahead and use the green one. So then we understand what the points are for the green guy. All right, so our points for the green guy are 0, 1, pi over 2, comma 0, pi. Actually, let's go back and give us some space so that we can not clump it all together. So take a look at your notes. So I'm just going to write down the points here. 0, comma 1, pi over 2, comma 0, pi, comma -1, 3 pi over 2, comma 0. Oh, ran out of space. Let's take this guy here, move it up. And 2 pi, comma 1. All right, so those are the 3 points we have for cosine. Now remember, the number in the front, the 1/3, right, the multiplier in the front is going to shrink vertically. Now since all of these numbers here, the y values are our vertical values, we're going to multiply all of those by the a value. Then we're going to take the 1/2, also known as your b, and we're going to flip it. Remember, we always want to use the inverted version of the value for the transformation on x. So flip the b, right? So flip 1/2, and we get 2 over 1, or just 2. That's going to change all of these values. So now what I'm going to do is I'm going to multiply all the x's by 2, and I'm going to multiply, right, all the x's by 2, and I'm going to multiply all the y values by 1/3. And this is going to give us a set of points that we're going to use to graph our function. So our first set of points, our x values, are going to come into 0 times 1/2. So we're going to go 0 times the 2, sorry, not 1/2, 0 times the 2. That would just be 0. Then we're going to multiply the pi over 2 by the 2, and that's going to give us pi. So we're going to write down pi right there. Then we're going to multiply the pi times the 2, and that's going to give us 2 pi. So all we're doing right now is we're horizontally stretching each of our x values. So 3 pi over 2 is going to get multiplied by 2. That's going to give us 3 pi. 2 pi is going to get multiplied by 2, which is going to give us 4 pi. So what we've done here is we've multiplied all the x values, 0, pi over 2, pi, 3 pi over 2, and 2 pi, by the flipped version of the b to get our horizontal stretch on all of our key points. Next, we're now going to multiply all of our y values by the A, or the 1/3. So all of those guys are going to get multiplied by the 1/3. So let's go ahead and do that. 1/3 times 1 is 1/3. 1/3 times 0, well, that's just 0. 1/3 times -1, that's -1/3. 1/3 times 0 is just 0. And 1/3 times 1 is 1/3 again. So we're going to have a 1/3 at the very end. Once you've done this, you've now set up the 5 points you need to graph the function. Now we're going to set the points on our graph. Since we know the graph is going to go to a height of 1/3, noticing that of all the values on the on the y, the highest it is 1/3, the lowest it is -1/3. We're going to make sure that we go up to 1/3 and as low as -1/3. Now, if you want to graph this as accurately as possible, that's your choice. If you wanted to say that that was 1/3 using each square as 1, you could. It would be a really hard graph to see, and I wouldn't recommend it, especially since I'm going to be grading you on your accuracy of your graph and whether or not I can see all the details about it. Next, the period of the graph is when you multiply the 2 pi by the reciprocal of b. In other words, the period is 4 pi. What that means you're going to want to do is you're going to want to extend the graph all the way out to 4 pi. Now, you can put 4 pi wherever you want. Just know that by the time you hit the end of the graph, you're going to see a full period of the function, or a full wave, one full wave of the function. That's the whole goal here. So I'm going to take this and I'm going to say, let's make it into four equal parts, because remember, the circle has 4 parts. So we'll say 1, 2, 3, and 4. So by the time I hit that point right there, I should have a full wave of the circle. You know what? I'm going to go out a little bit farther. Instead of going out 2, let's use the entire room of our graph. We're going to go 1, 2, 3, and 4. We're going to go all the way out to over there. All right, now, since the last one is going to be recognized as 4 pi, I'll put 4 pi right there. So the last point is going to be recognizing the end of the period. Now, the halfway point is going to be, well, exactly as it sounds, exactly in the middle of the first and last point. So notice that the halfway point is in the middle of the first and last point. Next, in the middle of the first and the middle, right here, is going to be this guy. So we're going to put pi in that position. So we'll put pi right there. And then that would leave 3 pi to be in between 2 pi and 4 pi. So everything is equally partitioned, equally intervaled, so that it represents the points that we need. Now we're going to go ahead and start graphing these points. 0, 1/3. I'll put that in black. 0, 1/3 is up over here. Now, as far as cosine is concerned, that makes sense. Our cosine function always starts at its maximum, at its apex. Then it's going to go to pi, 0. So I'll go over to pi and stay at 0. So I'll put a point right there. Next, we're going to go to 2 pi, -1/3. So we're going to go to 2 pi and then down to -1/3. That's going to give us our third point right there. Remember, we want to have 5 points plus a little bit more, and I'll talk about the little bit more in a second. Next, we're going to do 3 pi, 0, which would give us this point here. Now, this kind of makes sense if you're looking at it, because remember, cosine goes down, down, up, up. So we're expecting that to happen with our key points. Now, remember, it's not linear, so it's not lines, but the idea is the direction that it's moving. Is it increasing or decreasing? And then we have 4 pi, 1/3. So we go all the way to 4 pi, then we go up to 1/3, and we graph our next point. 4 pi, 1/3. Those are the 5 key points that we want. You're pretty much done with the graph. You just need to make the curve look really good. My suggestion is find 3 points that create a U shape or create an upside down U. Now, since these 5 points don't give you complete U's for 3 of them at a time, you're going to have to make sure you do plus. You're going to need a little bit more. So I would say that right there would give me my first U. So I'm going to go ahead and connect these 3 points here to get my first U looking shape. Now, the problem with this one is that some students will do that, and that is incorrect. This is why I want you guys to do 3 points, so that we get a U shape. Now, since this one doesn't have the U shape, then I would make sure that I do the plus, right? The plus point. So I need a little bit more to get that U shape going on. The same thing is true about the one over here. I need plus points. I need a little bit further out to understand that U shape. Now, the real graph that you're going to be graded on is that, but I'm going to focus primarily on this piece here, starting with our first dot, going through the red, the blue, the yellow, and then the green. That's what I'm going to be looking for. However, to get a really accurate representation of your function, you're going to want to go a little bit out to make sure that you're getting U-looking parts to the wave. All right, that's it for number one. Let's go ahead and try number two. So number two, we're going to graph f of x equals 2 sine pi x. To do this, the first thing we're going to want to do is make sure we know what the first points are. Now, you can always memorize it, or you can just think about your unit circle. Sine, when you use the unit circle, starts at 0. So then sine is going to go 0, 0. And then as you rotate around, it's going to go to pi over 2, comma, 1. It goes up. And then it's going to go down to pi, comma, 0. So it's going to go up. It's going to start at 0, go up to 1, go down to 0, and then it's going to keep going down. 3 pi over 2 is going to go down to negative 1. And then after you get to the lowest you can get, it's going to bounce back up to the middle at 0. Now, this 2 in the front is going to change all of these guys right here. So all of those are going to get multiplied by 2. So all my points are now going to be 0 times 2, 1 times 2, 0 times 2, negative 1 times 2, and 0 times 2. Well, let's try that again, except this time we're going to do it with the pi. Now, we're not going to just use the pi. We're not going to just use the b. We're going to do flipped of it. So we're going to flip it, and we're going to multiply by 1 over pi. The first one's pretty easy. So we're going to multiply all of these guys here by 1 over pi. So 1 over pi times 0 is 0. That's an easy one. The harder one is everything after that, but once you see it, it kind of makes a lot of sense. So I'm going to multiply everything by 1 over pi. Pi over 2, pi's cancel, and we get 1/2. So when the pi's cancel, we get 1/2. So I'm going to write 1/2 right here. Next, we're going to multiply it by pi. The pi's cancel, and we get 1. See how easy this one is? When the pi's in the denominator, it makes our life easy. Next one, 3 pi over 2 is going to get multiplied by that. The pi's cancel, yep, and we get 3 over 2. So if you're looking at this and you're saying, it looks like the pi's are just canceling, you've got it. The pi's are just canceling. Next, we're going to multiply by 2 pi, and that's it. The pi's cancel, and we get just 2. So we'll write 2 right there. I'll erase this guy here because we don't need it anymore. And we now have all 5 of our key values. Now remember, we might need extras, but these are the 5 we have. Now let's get into the graphing. Since the amplitude of the graph is 2, I'm going to make sure I go up 2 spaces. So I'm going to go up as high as that. So we'll call that 2, we'll call that 1. Now some of you are like, how do you know what to call it? You can make it whatever you want. If you wanted to call the first line, like if you really wanted to, if you wanted to be like, yeah, I'm feeling kind of lazy, I'm going to call that guy 2 right there, you could do that. I like to give some kind of perspective to it. So, a little bit larger, that would make sense. Now, if we were trying to stretch this with an amplitude of 100, yeah, I'd probably just go a little bit up. I wouldn't go that far out. Next, we're going to go ahead and graph the period version of it. So this is the final of the period. So we're going to go all the way out to 2. So I'm going to count, and I'm going to count by 3s again, just because I want to get as much of the graph in there as possible. Some people would prefer to count by 2s, in which case their graph would start, that would be the first quarter, the second quarter is off. You could do this. This would totally work as well. Right? So if you wanted those 4 points right there, that works. If you wanted to be even smaller, you're like, I only want to count 1 square at a time, you can do that as well. It gives you a smaller graph, harder to see for people. So I'm going to kind of, make it so that it's visible for everyone that's sitting in the class. All right, so we're going to partition it out over there. This is where the final value is. This is where the middle is at 0, 0, right? So that's 0 over there. Next, the middle guy is 1. In the middle of 1 and 0 is 1/2, right? So we're just graphing that. We're just putting it on the number line. And then we're going to put this guy on the number line between 1 and 2. That's going to be 3/2, or 1.5. All right, now we graph our 5 key points. So we're going to start with 0, 0. Remember, the sine function always starts at 0 when we graph it. Then we're going to start at 0, 0. Then from there, we're going to go bounce up to 2. So we're going to go over to 1/2 and then go up to 2. So we go over to 1/2 and then up to 2, and we put a point right there. Next, we're going to graph this point, 1, 0. So we're going to go over to 1 and not go up anything at all, which puts a point right there. After that point, we're going to go to 3/2, -1, so 3/2, and then down to -2. Sorry, not -1, down to -2, which would give us a point down here. And then we're going to finish off the graph at 2 comma 0. So we're going to go all the way to 2, neither up nor down. We're going to stay at 0 right there. All right, looking for points that make u's. Now, I personally like graphing the sine function over cosine because the sine function will always have the 3 points to make u's on them. Cosine always has like a half wave that's involved in there, and it kind of, I don't know, it throws people off mathematically, visually. There's your graph, by the way, and that's how we would graph 2 sine pi over pi x. All right, I'm going to leave the last problem for you guys to try. So go ahead and try this one here. I'll supply a second video that talks about the graph of that guy. But this is what I want you guys working on for your homework tonight. If you have any questions, hit me up via email, or you can just send me, you can talk to me tomorrow. All right. Have a great day, and I'll see you guys later.